Thank you so much, Dikshita. If you're all wondering, saying why it is me and not the talk featured on the website, which is virtual machines on GCP, that's because one of our speakers, Sumitra Vakchi, is actually affected by Cyclone Amphan, and she does not have network. So I just wanted to call her out, and our hearts really go out to people and communities affected by this disaster. Yes, so without much ado, I'm here to talk to you about ML explainability and trust. So this talk will cover more about how can we as product creators, developers, designers, understand the role that we have to play in ensuring that our users feel that they are in control of technology, and it shouldn't be the other way around. So here's my attempt to that. So if you were a part of Shweta's and Sriranjani's hands-on talk on introduction to neural networks, we actually went through this ML workflow of training your data, collecting data that you need, and then actually go on to build models, train them, and most importantly, at the end of it, deploy them. But there are a lot of other factors that we must consider. For example, in this case, it was a tutorial-friendly environment where you got a clean data set that you could easily use and parse. But often in reality, it's not the case. Having a very diverse data set that represents your problem really well is very important. And often this is a very time-consuming job. It can take even more time than actually building your model. So invest a lot of time in ensuring that you're collecting the right data sources and a diverse set of data to train your models so that our technology can perform better. The second phase in terms of model training and evaluation is we decide on the metrics that we want. So in this case, in the case of MNIST, where you were defining predicting what your digit would be, the accuracy was, the metric was accuracy, where you wanted to predict what would be the digit that, would come out of that character recognition. But it's not always easy. It's not as simple as that in real life, because one thing we need to understand is it's not always just a technical decision. Factors like what is the human impact that it will have, and what is that we need to optimize for, keeping in mind that human impact is an equally important thing. Last but not the least, we did see how a neural network is trained with probably a few lines of code. But in reality, you might be training really complex models. You might be training models where a doctor has to decide whether he has to operate on a certain patient or no, or where you have to decide whether you want to buy or sell certain stocks or no. So it's important that we consider these factors. And the people and AI research team actually works to ensure that we do enough research and design over building people-centered AI systems. So they released a book in Google I/O last year. It's a guidebook with 6 chapters on best practices on designing people-centric AI systems. This is an open source framework that will enable us to make more AI product decisions, which are more human-centered. So while it's for you to go and look at these 6 chapters, we're going to talk about one such one, which is explainability and trust. So the 2 concepts that we will primarily be covering in the next few minutes is how much should the user trust your AI system? And the second question that we'll try to address is how do we, as people building the software, give a certain confidence to our users on the prediction that we give them? So let's explore. Let's start with the first one of talking about trust. So here's a trust spectrum. You might find one set of people who have absolutely no trust in your system. They would probably have had a previous bad experience, or they think that the prediction or the recommendation that you're showing is not something that's too applicable to them, and they would just ignore it. There can be another end of the spectrum where they trust the system wholeheartedly. But this is not always ideal, because there's certain level of statistics and probability that's associated with giving certain confidence scores. So we as people building systems should really take care that we calibrate this trust for our users. Based on certain system explanations that we give them, the user should be able to, in some cases, trust the system, system's predictions, but often also rely on their own judgment to make the best decision for their solution. So yeah, so our intent should be to get the user to that middle ground of calibrated trust. So there are 3 questions that it's important to ask ourselves when we're talking about calibrating trust. First thing, about what are the stakes? We need to consider that there are a lot of situational stakes when it comes to user experience. For example, if you're talking about an AI-driven navigation app, it may not be necessary to tell the user how is the arrival time computed for a daily commute. But just imagine if the stakes are high and the situation is something that's less frequent. Say I want to go to the airport, and the arrival time is very dependent on whether I make it to time to get my flight or no. So in this case, it's important for the system to explain its limitations. For example, if a user, say, enters the destination as an airport, maybe we could have an indicator saying that the traffic data only refreshes every 1 hour. This way, the user will try to use his or her own judgment and take a decision such that he or she gets to the airport on time, but still relies on your system to a certain level of confidence. The second thing is also that we need to consider is the system data that exists. For example, if we are trying to build a music recommendation app and we are claiming that this is an app for all kinds of users, it's important for us to also consider that, say, we have never trained our model on death metal. So we really need to be careful that the users who would probably like death metal might stop trusting your system the next time. So again, having a diverse data source is equally important to establish this level of trust. There can be another interesting scenario where you're using a AI navigation app, which in the terms and conditions you say that do you give the app the access to your calendar data, which probably the user might not read and would just say agree and proceed. Which means that next time you might give 5 minutes before an appointment, you might prompt the user saying, hey, it's time to go. But the user might actually think that, hey, there's something fishy. How does this system know? So I think the middle ground here could be that you could let the system know about, explain your connected sources in some form of indication, and I'll be soon talking about the best ones. It could also be that you're giving certain features like opt-out feature at any time later. Say, I want to disable this feature for my phone. The user should have that control to do it. Last but not the least, it's also important for us to understand that there might be few domain experts using our system. And these domain experts are the ones who would probably scrutinize the prediction even more, right? So finding a middle ground, giving these indicators, balancing the mix between relying on system predictions and having the user rely on their own judgment is equally important to calibrate trust. One other thing that could actually help us calibrate trust is going to the second phase of my talk, which is about model confidence. How can we display certain confidence indicators for our users to build that trust on your system? Model confidence is nothing but a statistical measure of a certain level of prediction. right? So you remember the MNIST tutorial where you actually went and said that, hey, you printed the model confidence by saying that, with this accuracy is what I'm saying, a certain digit is, say, digit 9. So but for us to get to this phase, it's very important to test and iterate a lot. There might be variety of cases that you have to test to ensure that you come to this level of deciding, saying, hey, this is the level of confidence that I need my system to have all the time. Confidence level can also sometimes not be very impactful. So it's important that you decide when should you show it and when you can make do without it. For example, novice users might not be able to differentiate between, so how do I react to something that's 85.7% confident versus something that's 87% confident? So what this also can do is create some mistrust for our users. Maybe the less savvy users might just go ahead and trust your system, but there are ways to very gracefully manage this. Let me show you how. Let's walk through some design patterns for displaying confidence indicators based on different situations. This could either work standalone or hybrid in some cases. This can also affect the type of neural network that you want to build. For example, in case of MNIST, where you're predicting a certain digit, you probably use the sigmoid activation function. But for example, you're building a classifier and you might use a softmax activation. In that case, it's important to know this upfront, talk with your developers, know this upfront, so that this piece of information is valuable for you to design your entire AI system. So diving into each of these design patterns, the first way could be categorical visualizations. This is where we're putting confidence values into buckets of, say, high, medium, low, to let the user know that these are the variations that they could have. For example, this is an example of the Google keyboard where you're swipe typing something and there is a predictive text associated with it. It's important to convey to the user that the output that you find in the middle is the best match, and the one to the either sides is the next best match. It's also, if you quite closely notice, there's also an indicator with those 3 dots, which says that this is the best predicted result. So carefully making the user understand what the predictions mean and allowing them to make their decisions and take actions more easily really helps. So here's another example of another design pattern called N-best. So this is here, N could stand for any number. Say like you're wanting to display the top 1 or the top 3 or the top 5 results. This is what you use. So in case of this example where Google Translate wants to translate cool from English to Russian, while it gives you the top search in blue, it also gives you other alternate suggestions for user to decide. Often this is used when there are varying levels of, when there are lower levels of confidence. So this also allows the user to have their own judgment. Another indicator is the numeric indicator. It's also often risky because by using the numeric indicator, we are presuming that the users have good knowledge about probability. Novice users might not able to differentiate between an 80% confidence to something that's, a lower or higher. Or for example, if I'm using a music recommendation app all the time and I'm listening to a particular genre of songs, but it might still not give me with 100% confidence that I like this song. It might probably be a 97%. Novice user might get confused. So use this wisely. Another category or design pattern could be data visualization. This is where we are using graphical indicators. If you see, this is an example of diabetic retinopathy, where P stands for somebody who is like proliferatively, diagnosed with diabetic retinopathy, whereas N means like there's no diabetic retinopathy. But so this is primarily used when you have a range of alternative outcomes and you want to convey that to the user. Yeah, so these are, and often data visualizations would also require experts to actually work with you to give you this level of understanding. So yes, that brings me to almost the end of my talk with just different, helping you understand different design patterns on how you can show your model confidence to your users such that it is very clear to them and actionable. But let's do this together. If you can use the chat box to understand, just like to help me understand whether, like imagine you're building an image classifier wanting to help your users identify a certain breed of dog, say a Labrador or a Husky or a Poodle. What confidence design pattern might be most applicable to your users? If you could use the chat window and give us a few answers, I can quickly reveal the right answer to you very soon.